Look at anything around you: a cup, a chair, your own hand. Every one of these objects is built from atoms. And every atom is built from smaller pieces, electrons circling a nucleus of protons and neutrons. But here's a question that sounds simple, and turns out to be one of the deepest in physics. Why does an electron have mass? Why does it carry a negative charge? Nobody assigned these numbers. No engineer wrote them into existence. And yet, every electron in the universe carries exactly the same mass, exactly the same charge, without exception. Physicists call these fundamental properties. But calling something fundamental isn't really an answer, it's just where our explanations run out. So tonight, we're going to ask the question most people never think to ask. Where do mass and charge actually come from? And how far down does Y really go? To understand what fundamental really means, let's take something apart, piece by piece. A wooden table is made of wood. Wood is made of molecules. Molecules are made of atoms, carbon, hydrogen, oxygen, locked together in patterns. Zoom into an atom, and you find a nucleus of protons and neutrons, with electrons around it. Zoom in again, and protons and neutrons dissolve into even smaller particles called quarks. But try to zoom into a quark or an electron, and something strange happens: there's nothing left to find. No smaller pieces. No hidden gears. As far as every experiment ever run can tell, quarks and electrons are not made of anything else. This is what physicists mean by fundamental, not important, not special, just the bottom of the ladder. The last floor before the questions have to change shape entirely. So if electrons aren't built from smaller parts, where does a property like mass come from? The answer starts with a strange idea from quantum field theory: particles aren't really things at all. Space itself, every cubic centimeter of it, is filled with invisible fields. An electron field, a photon field, a field for every type of particle that exists. These fields stretch across the entire universe, usually lying calm and flat. A particle is what happens when one of these fields ripples. A tiny, localized vibration in the electron field is an electron. A ripple in the photon field is a burst of light. You are not really made of particles. You are made of overlapping fields, briefly excited into the shape we call you. It sounds abstract, but this framework predicts atoms, chemistry, and starlight, down to the decimal point. Now here's where mass gets strange. In 1964, physicists proposed one more field, filling all of space at every moment: the Higgs field. Some particles move through it freely, like a fish through water, unaffected. Photons, particles of light, barely notice the Higgs field at all. Which is why light has zero mass and travels at the fastest possible speed. Electrons, on the other hand, constantly interact with the Higgs field as they move, like wading through syrup. That resistance, that drag, is what we experience as mass. The more strongly a particle couples to the Higgs field, the heavier it is. And then there's the neutrino, nicknamed the ghost particle. It has almost no mass, and almost no charge, streaming through you, through the Earth, through stars. By the trillions every second, almost never interacting with anything at all. Mass, it turns out, isn't a built-in label. It's a relationship: how strongly a particle dances with the Higgs field. Charge works similarly: it emerges from deep mathematical symmetries baked into these fields since the universe's first fraction of a second. Physicists can measure these properties with extraordinary precision, predict them, build technology from them. But ask the deepest question: why do these fields exist at all? Why these particular values and not others? And science reaches its current edge. Not because the question is wrong, but because we haven't gotten there yet. Every fundamental answer in physics is really just the floor we're currently standing on, waiting for someone curious enough to dig one level deeper. Maybe that person is watching right now.